Alrighty, ladies and gents, how's it going? This video is going to be on the series, Basic Factoring Techniques. This one specifically on AC method factoring, and we're going to be messing around with this function here, yeah, I'm going to be showing you how to go about doing the AC method. Okay, so let's go about do it. Let's do it. Okay, so we recognize that this function is in a quadratic form, meaning that your f of x is equal to ax squared plus 5ax squared plus bx minus plus c, okay, plus c. In this case, your c is negative, okay, but this is the form of a quadratic equation, okay. So let's identify our a, b, and c term. So our a term is equal to 6, okay. Our b term is equal to 5, right? A, 6, b, 5, okay. All right. Then our c term, you have to make sure to include whatever sign it's in front of your, over here, your coefficients, or your isolated element, okay? So in this case, it's negative 6. All right. Yeah. So now for me, the interesting part of this algorithm is the part where you actually AC method, right? So a good way to show this would be to okay, here we go. Start off with an x. Okay, this is a good way to get your brain to work on these problems. So you have your a times your c up top. Down the bottom you have your b. Okay, meaning you're going to do 6 times negative 6 up top, right? And that's going to give you negative 36, right? So this part of the cross section is negative 36. A times c. You've done a times c, and you get negative 36. Okay. In the bottom, you only include your b term, so your 5. Okay. So all right. Okay. So now the question is, what two numbers add up? So let's just say z plus r. Okay. What two numbers add up to give you 5 that are also the same two numbers to multiply and give you and give you negative 36. Okay. So you're looking for two numbers that both add up to 5 and also multiply to negative 36. So the way you find this out, I'm not just going to spew the answer. Okay, I'm going to show you how to find this out. So for some quadratic functions it's going to work, for other ones isn't going to work. That's why there's a series about multiple ways of factoring. Because some work, some don't, some are easier, some are harder than others, depending on the function you're given, right? So, all right, you start off with to find your z and your r terms, right? You negative 36, okay, divided by 1, okay, and you get it is equal to negative 36, okay. Now, okay, so does 1 and negative 3 add up to 5? No, they don't. does 1 and negative 36 multiply to negative 36? Yes, they do, but because they don't add up to 5, we got to move on. Okay, so now negative 36 divided by 2. Okay, use my calculator for this. So negative 36 divided by 2 is equal to negative 18. Okay, so does adding up 2 plus negative 18 give me 5? No, it doesn't. Because it doesn't, we're going to move on. Because although they do multiply to give you negative 36, they don't add up to 5. We move on. So what about negative 36 divided by 3? Okay. All right, negative 36 divided by 3 is equal to negative 12. All right, so does adding up 3 plus negative 12 give you 5? No, it doesn't. Does it multiply to give you negative 36? It does, but because it doesn't add up to, again, it doesn't add up to 5, we got to move on. Okay, now negative 36 divided by 4, okay, so negative 36 divided by 4 is equal to negative 9, okay. So now we've stumbled onto something here, okay. We have 4, and then we have negative 9, okay. Does adding up negative 9 to 4 give you 5? Well, let's see. So 4 plus negative 9, okay. 4 plus negative 9 is equal to negative 5. Okay, so we have a 5. We want a 5. We don't want a negative 5. We want a positive 5. But we're getting close. Okay, we can multiply these two to get negative 36. So what if we do 9 plus negative 4? Okay. All right, let's see. 9 plus negative 4 is equal to 5. There we go. This is it. 9 times, okay, 9 times negative 4 is going to give us negative 36. Okay. And also 9 plus negative 4, okay, 9 plus negative 4 is going to give us 5. So we have found our z and our r terms, okay? So now we choose which one do we want to put which. You can put z over here, you can put r there, or you can put your r over here or your z here, okay? Important thing is you put them on the cross section. So I'm gonna put 9 right here, and I'm gonna put negative 4 there, okay? All right. I recommend taking a look at this because I'm gonna erase some part of the board. 3, 2, 1. Okay. If you need to take notes, you can always stop the video because this is a video. Okay. All right, so, okay, so with this data here, okay, what do we do with this data? Okay, what do we do with these numbers that we've computed? All right. What do we do with that? Okay, so what we do is we now we make a box. Okay, we make a box. All right. On this side of the box, we put our entire ax squared term, and then on this bottom part of the box, we put our entire c term. Okay, and then on these corner boxes, you can either put r here or z here. So the numbers we computed here, so z and r, right? You can put them here on these corners, or you could put z up here, z or r. These are interchangeable. Just make sure that your z and your r terms go in either one of these two boxes. Okay. I'm going to say I want my 9 to go here, and I want my -4 to go here. Right? What is my ax squared term? It's 6x squared. Okay, 6x squared. Now what is my c term? It's -6. Okay. All right, let's do away with this cross section. It has been useful to us up to this point. Now we have a box. What do we do with this box? So I call this the factoring box. Many people use it. Okay, it probably has many names, but essentially what we do is you do a version of factoring that is two-dimensional. Okay, so again, we're going to take our z and our r terms. We're going to make sure to add an x on them. Okay, because what we've essentially done here is that we have, if you've seen the factor by grouping, we have essentially split up. We have essentially split up this function. This function here, we've split it up to this, which 9x minus 4x is equal to 5. We have our 6x squared and we have our 6. So both of these are equal to each other. We have, in fact, rephrased the function to our benefit. Okay. So yeah, now you can either continue with this box or you can continue with normal factor by grouping technique. Okay. So I'm going to do both of them here. Yeah, but okay, so again, with these, you want to look at these boxes kind of like how you look at coordinates, like a coordinate system. Okay, so all right, so these two terms here, 6x squared and 9x, they both share an x. So we bring out an x. Okay. This 6x squared and that -4x, they also share a x value, so bring out that x. All right. Now we can say that we can divide -4 and 6, both of them. We can divide them by 2. Therefore, 2 is a factorable number out of these two numbers, so we can say 2. All right. And we can say that we can say that 3 is a factorable number. 3 is a factorable number between these two numbers. So we can say 3x. We can divide 9 by 3. We get 3. We can divide 6 by 3. We get 2. Okay. So we factor out 2x. We factored out 3x. Now, okay, so now we have 3x. Okay, so what times 3x is equal to 2x? Well, 3. Okay, 3x times 3 is equal to 9x. All right. Okay, and now what times 2x is equal to -4x? So you say -2. -2 times 2x is equal to -4x. All right. So let's see. So now this here agrees with this. All right. 3x times 2x is equal to 6x squared. This 3x agrees with this side. Okay. So 3x times 3 is equal to 9x. Okay. This 2x agrees with this this bottom side here. Okay. So 2x times -2 is equal to -4x, and this 3 agrees with this corner here. Okay, 3 times -2 is equal to negative 6, okay? So essentially now we can, you see let me pick out a different color marker for this. You see these terms here? Man, that's a really nice blue. Okay. You have your function, you set it up, all right? That 3x minus 2 becomes its own parentheses, okay? And then you have your 2x plus 3, okay? Your 2x plus 3 because the 3 is a positive, right? Boom. You factored out, you completely factored out this function here. So again, you know, if this doesn't work for you, you can do, after you do your AC method, you can then do the last method for factor by grouping, right? Where you find you group these elements here, okay? So 3 and 9 are divisible by 3, okay? 3, and they're also divisible by x because they both share an x term, okay? So you can say 3x. You can do that, okay? So 3x. Then when you divide 6x by 3x, you get 2x, okay? One of the x cancel out, the one up top, right? Because there's one at the bottom. And the 6 divided by 3 becomes 2x. And again over here, so your 3x. 9 divided by 3 is equal to, again, positive 9 divided by 3 is equal to 3. And then the x's cancel out. All right. And then after that, you look at this group here and you try and factor it. So we got negative 4x minus 6, okay? So we can factor out a 2. We can factor out a negative 2. See how both terms share a negative, okay? We can factor out a negative 2. Okay? And what happens when you divide negative 4 over negative 4x over negative 2? Well, you get positive 2x. Okay? And then what happens when you divide negative 6 over negative 2? You get positive 3. Okay? Point being, now you're left with this, okay? If you've seen the factor by grouping video, now you have both of these terms here, okay? Which, because you have two parentheses that are the same, and then you have your you have different factors going into them. What you can do is you can rephrase this expression as 2x plus 3 times 3x minus 2. Okay, is that? Yep. There you go. Okay. So now, you know, we have this here and we have this one up here. Okay. Are they the same? Well, you know, apart from one having the 2x plus 3 term on this side, 3x minus 2 on this side, they are exactly the same. The process of multiplication, is commutative, so you can have So long as your terms inside your parentheses have like a parentheses, right? You can have your b, your parentheses b and your parentheses a be interchangeable as long as they're multiplying against each other, and that's happening here. Okay, we have 3x minus 2, then we have times 2x plus 3, and yeah, I mean one is over here and one is over here. But because of the commutative property of multiplication, it's okay to have them on both sides. 3x minus 2 times 2x plus 3, and then 2x plus 3, 3x minus 2. And now the last step, I mean, let's verify that these are ultimately equal to this function that we started off with, okay? So we can choose either one. Let's choose this one up top. Okay, so f of x is equal to 3x minus 2, 2x plus 3. Is this visible on the thing? Oh, I'm writing into a not visible zone. Okay, there you go. So again, we distribute. Okay, so 3x times 2x is equal to 6x squared. Now we have 3x times 3, which is equal to 9x, all right? Then you have negative 2 times 2x, which is equal to negative 4x. And then you have negative 2 times 3, which is equal to negative 6. There you go. And then you add up the like terms, okay? You add up the like terms. 9x minus 4x, both share that same x term. So you can add them together. They're like terms. And we ultimately get 6x squared plus 5x minus 6, which is equal to the beginning function that we started off with. We have, in fact, properly completely factored out this this function. Let me yes, 2x. Alrighty, let me step back. There you go. That's your take notes, if you will. And alrighty, deuces. I'm going to erase this. Erase 5x. Yep. All right, awesome. Alrighty. Oh yeah, the video is done at this point, so you can stay to watch me erase this thing if you want. If not, you can continue on to the next video. Yeah, if you stayed this far, like and subscribe. Okay. I gotta get some board cleaner liquid. Alrighty.